With the first pick in the 2025 First Year Engineering Design Day Draft, or FEDD for short, the automatic chicken coop doors select Poultry in Motion.
And there you have it, the number one overall pick, Poultry in Motion. Really no surprise, most overall well-rounded team. Just a great selection. Now to the sideline reporters for more on the pick.
I would say that there was a lot of design challenges that we had to face. There was one main problem was the actual design. We had two designs at the beginning of our brainstorming, but we ended up going with a linear actuator design. The linear actuator did bring on some problems. We were trying to figure out how to attach something that would go up on the side and then also right here on the side and make them move together. So we just kind of slapped something on top, and that was our problem to there. That was our fix to there. And then we had a problem at the competition that our connection was actually weak, and we didn't actually get to test that too much. But we pushed through and we duct taped it to the door, and it made it more structurally sound than it was before. And yeah, I mean it still broke, but I think we redneck engineered some duct tape on there, and it pushed through, and it worked. It was really good. But that was most of the problems that we faced during our project.
Our automatic chicken coop door that's constructed out of 1x4-inch lumber and a 2x10-inch lumber with some 3D printed sorted parts. It works by using a linear actuator to move the door up and down, which rides along a drawer slide to keep it in line, and it is controlled by a electronic setup that consists of a photoresistor to tell it when to open and close, an Arduino, and a motor controller that actuates the linear actuator. During the testing phase, we tested it during different times of day with different light levels to hone in the photoresistor's readings, and that allowed us to set it to open when the sun rises and close when it sets.
We used the engineering design cycle in every single step of our design process. First, we had to ask, what are the constraints and what are the requirements that we had to meet in order to make this project successful? This included the budget, the length of the door, anything that you can imagine. Next, we had to actually go out and research real life solutions to this problem, such as what does a chicken coop door look like actually in practice? Why do we need a chicken coop door? Everything that goes along with that. Next, we had to imagine. Now, this part was fun because we had to imagine different possible solutions to this. So our door could go up and down, it could draw out like that, it could fold up like that, it could go side to side, anything. So eventually on our plan setting stage, which is the next stage in the design cycle, we chose a door that moved up and down and was horizontal. So next we had to actually create a prototype of using our plan. And so this was definitely the longest part of the design cycle, but I think it was the most fun because we actually had to implement our plan. So we had to go out, we had to get the materials, we had to gather them all together and create an actual prototype of our design. Next, we went into the design process. So this is just pretty much as it is, pretty much what it's saying. We took our design and we tested it and we evaluated what were the weaknesses, and we went on to the next step, which is improve. And so we realized that there was a structural weakness in our 3D printed part, so we had to improve that in order to make our design more successful and better suited to fit the requirements at the beginning. Thank you.
Thank you, Zane, Brant, and Jay, for that wonderful analysis. Now to Caden, out in the field, for a reflection and encouragement moving forward.
For our automatic chicken coop door, we spent most of our time building our project at this table right here in the Sullivan Lounge. Also in the Sullivan Lounge is the makerspace, which is a good space to get a lot of your materials for free and can help with your budget. For our project, some of the things we struggled with was the electrical components. In our group, we didn't have a single electrical engineer, and that hurt us because by the FEDD day, none of our electrical components worked basically, so we were plugging our cord or our thing straight into the battery. For next year students, freshmen coming in, I would recommend starting early, picking a project that is specific to y'all's majors, and using all of the resources available. Good luck and thank you.
Thank you, Kate. And thank you for watching the first year Engineering Design Day Draft. It's been a pleasure. Thanks for tuning in. We'll see you next time.